Hello everyone. In my previous video, I have told you the Laplace equation and its solution. Okay, and in this video, I am going to tell you the proof of one-dimensional wave equation, which is very important for B.Tech and B.Sc students. That is for physics honors and mathematics honors students. Okay, and for one-dimensional wave equation, we have to consider the stretched string, which is very important for musical instruments containing the string. Okay, here. See here, this is x-axis and this is y-axis, and this is the string, and whose two endpoints are O and A. O and A are the fixed ends of the string. And let us consider 2 points P and Q on the string which are very close to each other. Condition is that P and Q are very close to each other. And the abscissa, that means x coordinate of the point P is x, and the abscissa of the point Q is x plus delta x. That means the x coordinate of the point Q is x plus delta x. So that this distance will be delta x. Clear? And if P and Q are very close to each other, then the distance PQ will be equal to delta x. Okay. So since P and Q are stretched, that means we are applying the force at the two ends away from each other. Then only the string will be stretched. Okay. So T2 will be in this direction, which is the tension at the point Q, that means along the tangent and away. And the tension at the point P is T1, and whose direction is along the tangent but in this direction. Since they are in opposite direction, the string will be stretched. Okay. Let the tension T2 makes an angle beta with the horizontal, and the tension T1 makes alpha angle with the horizontal. So let us resolve T1 and T2 in rectangular coordinate components. That means one vertical component and another is horizontal component. So the component which is attached to alpha will be cos. That means T1 cos alpha. And the other component will be equal to T1 sin alpha. Always remember, the component attached to the angle, given angle, will be cos, and the other component will be sin. So the component attached to alpha is T1 cos alpha, the other component will be T1 sin alpha. Clear? And here T2 is the tension which makes angle beta with the horizontal. So horizontal component will be T2 cos beta, and this one is T2 sin beta, the vertical component. As we know that, how I have chosen here, see here, if the resultant is in this direction, then this will be the horizontal component, this will be the vertical component. And if the resultant is in the second quadrant, then this will be the vertical component, this will be the horizontal component. If the resultant is in the third quadrant, then this will be the horizontal, this will be the vertical component. And if the resultant is in the fourth quadrant, this will be the horizontal component, this will be the vertical component. Clear? So here, this is the vertical component of T2, this is the horizontal component of T2, and this is the horizontal component of T1, this is the vertical component of T1. Okay. And the string is vibrating up and down. Now, in my figure, it is in the upward direction. And always the string will vibrate vertically, not horizontally. Clear? That means the horizontal components will remain constant. Only the vertical components will vary. Okay, so let us say here, let us consider the motion of a stress string fixed at its ends O and N. This one is A. Clear? And N is the length of the string. M is the mass per unit length. Mass per unit length, not only mass. Don't take only mass. Mass per unit length. And delta x is the length of the small portion PQ. And y is the vertical displacement. up and down of the string at any instant of time t. And T1 is the tension at the of the string at the point P, and T2 I have taken the tension of the string at the point Q. And what are the assumptions? You have to assume something. See here, the assumption is the string is homogeneous and perfectly elastic. The string should be homogeneous and perfectly elastic, otherwise it will not vibrate. Without elasticity property, it will not vibrate. Okay. The tension is very large compared to the weight of the string. That means the string should be very thin, okay, and the tension should be very large. So that gravity has no effect on the string. If the weight will be very less, it has no effect. Gravity will be, the effect of gravity will be zero. That means it will be negligible. Okay. If there will be weight of the string, that means the gravity will apply the force, that means mg, which is the weight of the body. If weight is negligible, then the gravity has no effect on the string. Okay. The motion of the string is transverse vibration in a vertical plane. Transverse vibration, not like this. It will be longitudinal and transverse vibration. That means like this. See here. This is the transverse vibration, and this will be the longitudinal. So it is in this form. The string will vibrate like this. Okay. See here. These are the conditions. And now I have told you that the string is vibrating vertically. There is no horizontal displacement. That means the horizontal component will be equal to each other. That means the sum of the horizontal components will be equal to 0. That means this component T2 is along positive x-axis and T1 cos alpha. T2 cos beta is along positive x-axis. T1 cos alpha is along negative x-axis. They are in opposite direction. These two must be equal. Must be equal. If they are not equal, then there will be displacement along horizontal direction. Okay, that means T1 cos alpha is equal to T2 cos beta. Let it be T side. I have taken T. Okay, and according to Newton's second law, force is equal to F is equal to ma, mass into acceleration. So net force is equal to mass into acceleration. So net force, that means in my present figure, the string is vibrating in the upward direction, not in along the downward direction. And since the string is along upward direction, so the upward component, that means T2 sin beta, will be more than the downward component T1 sin alpha. So the resultant force will be T2 sin beta by T1 sin alpha. And if this string, if I take in this direction, then T1 sin alpha will be more than T2 sin beta. Okay. So see here, T2 sin beta minus T1 sin alpha. This is the net force. And mass. What is the mass? Mass, m is the mass per unit length. I have taken mass, m is the mass per unit length. So 40 portion PQ, what will be the mass? M is the mass per unit length. For unit length, m is the mass. And for length delta x, because PQ is delta x, so the total mass will be equal to m into delta x. And acceleration, it is the second derivative of displacement. As you know, why is the displacement? See here, why is the displacement? So del y by del t is the velocity, and again del by del t of del y by del t, which is equal to del square y by del t square. This is the acceleration. First derivative of displacement with respect to time is velocity, and the second derivative of displacement with respect to time is the acceleration. Okay, so see here. So in place of acceleration, I have written del square y by del t square. Okay, so I have taken T1 cos alpha is equal to T2 cos beta is equal to T. So I am dividing T on both the sides. Here, divide T on LHS and RHS. So in place of T, I have taken in the first term T2 cos beta, because T2 is there, so I have taken T2 cos beta. And here it is T1, so I have taken T1 cos alpha in place of T. And here I have taken T, because already I have taken T1 cos alpha is equal to T2 cos beta is equal to T. So now see here, T2 T2 cancel out, sin beta by cos beta it is tan beta, and T1 T1 cancel out, sin alpha by cos alpha tan alpha, and this remains same. And according to calculus, tan theta is the slope of the tangent. Okay, but according to calculus, del y by del x is the slope of the tangent. According to coordinate geometry, tan theta is the slope of the tangent, so theta is the angle of inclination, and del y by del x is the slope of the tangent according to calculus. So in place of tan theta, I can write del y by del x. So here I have taken beta, and beta is the angle of inclination at the point Q. See here. Again I am showing you the figure. Beta is the angle of inclination. That means the angle which the line makes with the positive x-axis. Beta is the angle of inclination of T2. Okay. And it is at the point Q. And alpha is the angle of inclination at the point P. So that is why in place of tan beta, I have written del y by del x. That means slope at the point Q, where the x coordinate is x plus delta x. And in place of tan alpha, I have written del y by del x, slope of the tangent, and whose x coordinate is x. And right hand side remains same. So dividing delta x on both the sides. Here delta x cancel out. M by t del square over del t square. And the formula for derivative f dash c. See here, f dash c is equal to limit delta x tends to 0 f of c plus h, or I can write c plus delta x minus f of c divided by delta x. See here, f dash c, that means del f by del x at x is equal to c. I can write like this one. Limit delta x tends to 0 f of c plus delta x minus f of c divided by delta x. Here see, in place of f I have written del y by del x at x plus delta x, del y del x at x divided by delta x is equal to m by t del square over del t square. And if we take limit delta x tends to 0, limit delta x tends to 0, then this will become derivative of f, the function. Here derivative of del y by del x. That means this left hand side after taking limit, it will become derivative of the given function, and here function is del y by del x. This one. That means del square y by del x square. Del square y by del x square is equal to m by t del square y by del t square. Right hand side remains same because there is no delta x on the right hand side. So the limit will not change anything on the right hand side. Okay. See here. That means del square y by del x square is equal to m by t del square y by del t square. And what is the value of del square y by del t square? M by t will come to the left hand side. It will become t by m. So del square y by del t square is equal to t by m del square y by del x square. And in place of t by m, I am writing c square. Okay, T is the tension, M is the mass per unit length. So square root of T by M is C. So del square by del T square is equal to C square into del square by del X square. This is the one dimensional wave equation which governs the transport vibration of stress string. And for stress string, the formula is this one. Del square by del T square is equal to C square into del square by del X square, and where Y is the displacement. Okay. So in some books it is given that del square U by del X square. Del square U by del x, or here del square U by del t square. In that case also U represents the displacement at any instant of time t. That means here, see here in some books it is given y of xt here, or in some books see here y of xt, and in some books it is given that u of xt here. Y is the displacement at the point x at time t. U is the displacement at the point x at time t. So same thing, you can take y or you can take u. According to your question, you should do the derivation, and accordingly the problem should be solved. Okay. So this is all about the derivation of one dimensional wave equation. In my next video, I will tell you how to solve the problems based on wave equation. Till then, bye bye.